Grok AI was asked how Egyptians cut solid granite. Its answer stunned researchers. In the granite quarries of Aswan, in the far south of Egypt, where the Nile narrows and the desert presses in from both sides, there are cuts in the rock that have puzzled people for over 100 years. Not because they're hidden, not because they're hard to find. You can walk right up to them. But because when you look closely at how smooth, how curved, how strangely consistent some of these marks are, a simple question starts to nag at you. How did anyone do this by hand? That question got a new twist recently, when clips started circulating online claiming that researchers had fed scans of these cuts into Grok, the AI system built by XAI, and that the AI's answer shocked everyone in the room. The claim spread fast. Different channels, different narrators, the same core story. An AI with no knowledge of Egyptology looks at cold data and concludes the marks match machine tools, not human hands. It's a great story. It's also, as far as any of us can verify, not a real documented study. There's no named research team behind it, no university, no published paper, no data set anyone can check. What we do have is something almost as interesting, a real archaeological mystery underneath the viral claim, and a real, very human reason why stories like this spread so easily. So let's actually go there. Let's look at the stone itself, what we genuinely know about how it was cut, where the real uncertainty lies, and why an AI said so is such a tempting shortcut when the truth is messy and, honestly, more impressive. Start with the place itself. The Aswan quarries don't look like much at first. There's no temple facade, no crowd of tourists, no velvet rope. Mostly you see half-finished blocks lying exactly where they were abandoned thousands of years ago, rough shapes cut partway into the bedrock and then left. The most famous of these is the unfinished obelisk, a granite spire that would have stood over 40 meters tall and weighed something like 1,200 tons if it had ever been freed from the rock. It wasn't. A crack appeared partway through the cutting process, and the whole thing was abandoned in place. That accident is actually a gift to us because it froze the cutting process mid-step. You can see the channels workers cut around the stone, the pounding marks in the trench walls, even some of the tools left behind. This is not a mystery site in the sense of nobody knows anything. It's one of the best documented ancient quarrying operations on Earth, precisely because the work stopped before it was finished. Now, why is granite the centerpiece of this story rather than, say, limestone? Because granite is genuinely hard. It's an igneous rock, formed under intense heat and pressure, made of interlocking crystals of quartz and feldspar. On the Mohs hardness scale, it sits around 6 to 7, well above the copper tools Egyptians are known to have had in abundance. Copper on its own would barely scratch granite. That's not a controversial statement. It's basic materials science, and it's exactly why the standard explanation for cutting granite has never simply been they used copper chisels and pushed hard. The standard explanation is more layered than that, and it's worth actually laying out because most viral videos skip straight past it to get to the impossible part. The mainstream, evidence-backed picture goes like this. For the heavy initial work of separating a block from bedrock, workers used dolerite, a very hard, dense stone shaped into rounded handheld pounders. Thousands of these dolerite balls have actually been found at Aswan, sitting right there in the quarry, some of them worn smooth from use. Using them to pound channels into softer surrounding rock and gradually isolate a block is not a theory dreamed up in a lecture hall. It's been demonstrated. Archaeologists and engineers have replicated it. It's slow, it's exhausting, and yes, it does produce a rougher surface than the smoothest cuts we see in some places, which is an honest and important detail we'll come back to. Alongside pounding, there's strong physical evidence for fire setting, meaning workers heated the rock surface with fire and then doused it with water or let it cool rapidly, causing the outer layer to fracture and become easier to remove. This isn't speculation either. Evidence for fire setting has been found at multiple points in the Aswan quarry complex, not just at the unfinished obelisk. For finer, straighter cuts, especially where sarcophagi and finished granite objects needed flat surfaces or drilled holes, the evidence points to copper tools used with an abrasive, typically quartz sand, which is harder than copper and does the actual cutting while the copper tool just guides and applies pressure. Copper tubular drills packed with wet sand have been experimentally shown to bore into granite this way, and they leave behind a very specific signature: spiral striations on the inside of drilled cores that match cores actually recovered from Egyptian sites. This is one of the more satisfying pieces of evidence in all of Egyptology, because it's not an interpretation, it's a physical match between an experiment and an artifact. So the honest picture is not one tool, not one technique, but a layered process. Rough removal by pounding and fire setting. Fine shaping and drilling by abrasive-assisted copper tools. Final smoothing and polishing by finer abrasives rubbed by hand or with simple leverage devices. And all of it multiplied across an enormous, well-organized labor force, because Egypt at this point in its history had exactly what a project like this requires: centralized authority, food surplus to support full-time, specialized labor, and generations of accumulated stoneworking experience passed down through dedicated crews. None of this required lost technology. It required time, organization, and expertise that we sometimes underestimate because we're looking at the finished result and forgetting the process behind it. Here's where the real, non-fabricated tension comes in, and it's worth being honest about it rather than pretending everything is fully settled, because it isn't. When modern experimental archaeologists have tried to replicate dolerite pounding under realistic conditions, using real people with real arms, swinging real stone hammers for real hours, the results are rougher and less uniform than the smoothest cuts found in parts of the quarry. That's a genuine, documented observation, not a viral fabrication. Human muscles fatigue. Grip loosens. The angle of a swing drifts over time. This is basic biomechanics, and any honest experiment shows the same pattern. Early strikes are cleaner, later strikes get messy as the body tires. So when you find sections of cut granite that show unusually smooth, evenly spaced, almost regular curvature, it's fair to ask questions. Some of that variation is explained by which technique was used where. Fire setting followed by pounding removes a different amount of material than pure percussion. A skilled worker doing careful, slow, controlled shaping produces a different signature than someone working fast under time pressure. An erosion over 4,000 years, plus later restoration and cleaning at tourist sites, has smoothed and altered surfaces in ways that are easy to mistake for tool marks. None of that adds up to an AI concluded machine tools were used and shocked the room. It adds up to stone tool marks are genuinely complex to interpret, and serious researchers are still refining exactly how much of the variation comes from technique versus time versus erosion. Which brings us to the AI claim itself, because it's worth actually thinking through why this story took off the way it did, since that's a real and interesting phenomenon, even if a study isn't. Feeding photographs or 3D scans into an AI system and asking it to compare surface patterns against a library of known tool signatures is a legitimate kind of analysis, in principle. Pattern matching is something modern AI systems can genuinely help with. And archaeologists use computational tools, photogrammetry, and machine learning to study where patterns, tool marks, and material signatures. That part isn't fantasy. What's missing from every version of this viral story is any actual trace of the study behind it. No named lead researcher. No institution you can look up. No published data set. No peer review. No response from Grok's own developers confirming any such analysis was performed. What you find instead, if you go looking, is dozens of nearly identical YouTube scripts, all describing the same 847 cuts. The same dramatic silence fell over the room moment, recycled across different channels with different narrators reading almost word for word the same beats. That's not what a real scientific finding looks like spreading through the world. That's what a content template looks like spreading through YouTube. And it's worth naming that plainly, because it changes how we should treat the claim. Not as evidence of lost ancient technology, but as evidence of how effectively a well-built narrative, wrapped in the authority of AI said so, can spread regardless of whether anyone can verify it. That doesn't mean the underlying human fascination is silly. It's not. There is something genuinely stirring about standing next to a piece of stone that a person shaped with their hands 4,000 years ago, especially when part of that surface looks almost too clean to be believed. The instinct to ask, wait, how did they actually do this is a good instinct. It's the same instinct that drives real archaeology. The problem isn't the question. The problem is reaching for an AI proved it was aliens or lost machines as a satisfying answer, when the real answer, patient organized labor, layered techniques, generational expertise, is arguably more impressive, not less. Tens of thousands of workers coordinating in shifts, moving hundreds of tons of stone using nothing but rope, sledges, levers, water for lubrication and cooling, and an intimate, hands-on understanding of how granite fractures and responds to heat is not a small achievement you should feel disappointed by just because it doesn't involve secret machinery. If anything, it says something remarkable about what coordinated human effort and inherited craft knowledge can accomplish without any of our modern tools at all. So where does that leave the actual mystery? Because there's still a real one worth sitting with. Egyptologists don't claim to have every technique fully nailed down. There are genuine open questions about exactly how certain very smooth, very precise surfaces were achieved, particularly in a small number of finished granite artifacts like sarcophagi and vessel fragments, where the level of polish and symmetry does push right up against what we can currently and confidently replicate with known ancient tools. Serious researchers, not viral video narrators, are the ones actually debating this, comparing tool mark databases, running controlled abrasion experiments, and publishing findings that get checked by other experts. That's slower, it's less dramatic, it doesn't have a single stunning the room went silent moment, and it will probably never trend the way a fabricated AI reveal does. But it's the version of this story that's actually true, and it's the version that respects both the ancient Egyptians who did this extraordinary work and the researchers today who are still carefully piecing together exactly how they did it. If you want the honest headline instead of the viral one, here it is. No credible study exists showing that an AI analyzed Aswan's granite cuts and concluded machine tools were used. What does exist is a documented, physically evidenced, multi-technique quarrying process involving dolerite pounding, fire setting, and copper and abrasive cutting, combined with a small number of genuinely puzzling fine details that real archaeologists are still working through using real methods, not internet folklore. The stone at Aswan doesn't need an invented mystery to be worth your attention. It already is one of the most remarkable engineering stories from the ancient world, built by people, using patience, organization, and hard-won craft knowledge, and that story deserves to be told accurately rather than dressed up in a fictional AI twist to get clicks.